I'm writing a compiler for my Elna programming language. This is a self-hosted compiler. That means that the compiler is written in itself and it only uses the features that are already implemented, so we cannot use the full language yet. And today I continue to work on the intermediate representation. So we have two of them, but the second one is almost assembly, and the first one is more high level intermediate representation, and we have a type which represents possible operands to the intermediate representation. The first one is TIC 3 address code, and the second one is RTL, register transfer language. And the TAC has this temporary operand type, and this temporary operand type is a temporary register, so it is a hardware register, but it shouldn't because this intermediate representation shouldn't care about hardware registers. So we have to replace these temporary registers with temporary variables. Temporary variables are this pseudo operand type, and we are going to the generation of this intermediate representation in the binary expressions. This will be called TIC binary, and I have here already a temporary variable, so I use a static name LHS. We will fix it later, not today, so that a variable is automatically generated, but it doesn't matter currently. And at the end of this binary expression procedure, we create an instruction which copies the value from this LHS variable into a temporary register, and we want to get rid of this instruction. So the instruction itself is created in an if-else-if block or blocks. And the first thing we want to write it everything at once. That means that the code after we want to copy the code after these if branches, we will copy it into the branches itself, so that we can change afterwards single branches. It will be repeated everywhere for now, but we just need it for the development. We will fix it later. So basically I'm just going to copy all this stuff in every branch. Let us put a semicolon everywhere first. And then we copy it in here. I think that these branches handle all the possible values, so I hope that this thing isn't needed anymore. And we go to the first if branch. This is a plus instruction. Plus is actually used everywhere. We can probably take something that is less used. I'm not sure. Let us try with the AND instruction. So it's logical AND. And everything we want to do, we want to say that the value of the binary expression is saved in a pseudo register and not in a hardware register. And this pseudo register is called LHS, and it's 4 bytes for characters long. So, and we do not need this instruction anymore. It's actually not right. Of course, I do need this instruction. So I handle the LHS value first, and LHS is saved in the LHS variable. And I think that we can just create a second variable for now that we call RHS, and in this RHS variable we will save the result of the binary expression. So we just we say that we will save it in RHS, and this is the binary instruction itself, an instruction for for a binary expression. This is the LHS value. So I just reuse the same, the name is a bit misleading. I use the same LHS variables for the left hand side and right hand side, but left hand side is saved in this LHS pseudo register. So, and right hand side was handled before, so we just need to replace the target register with R. RHS is actually also a stupid name. Let us call it binary. 1 2 3 4 5 6. Let us call it binary. And it doesn't fail. Okay. Then we do the same for the logical OR, so we call it binary and make it 7 characters long, and it is a pseudo register, not a temporary variable. So sudo binary, and I made a mistake here. Let us look what happens. And this one fails. And now we see illegal operands. This is an error message from the assembly, and it complains about invalid illegal operands. So binary is written verbatim, and we have to fix this. I split my screen into parts, and we will look where the assembly is generated. It will be an RTL instruction function probably. Elna RTL Waterbrand address. So we have this LNRTL binary arithmetic procedure which handles the binary operations. What was the error once again? I think that the first operand is invalid, and we just copy this operand, and of course it doesn't work. So yeah, the problem is that these pseudo variables, they are allocated on the stack. So after we calculate the result of this binary expression, we need to save the value from the target register on the stack. But pseudo register are actually available also here, because they will be needed later. This RTL path is the path where we will do the register location, and pseudo variables are still possible here. So probably we have to look into a later path. I have this alloc path, and it looks into the instructions. Yes, I think this is the thing that we need. This is load storeword load address. And I would say, let us just create an else if block and check whether the operator is an OR instruction, I think, or is written with underscore, because OR is a keyword. So exactly we check whether it is an OR instruction. And probably we have here something similar. So after that I check the operand type, that we can do the same. So we query the fields of the first operand, and we check whether the target or the operation is a pseudo variable. If this is the case, we can replace the first operand, the target register, with a hardware temporary register. The first operand of the instruction is then ELNA RTL operand register. I used there 6. I'm not sure which register it is. Doesn't. Oh, we can check it probably. T0, I think. 1, 2, 3, 4, 5, 6. So with T0, the length is 0, and we are missing one argument, this RTL operand register. this could even work, or probably not. Now it breaks. This is expected. And after that, we need to allocate space on the stack for this binary variable, and we need to load the value from this T0 register into this stack spot. So I go back here. Operand value, operand length is fine. And we need to generate a store instruction here, and I will probably do the same as I do here. Just so we first copy the alt instruction into a variable, and then we use this instruction variable for the new instruction. So for the last instruction needed to write this operation, it is done this way to concatenate. So instructions are a list of instructions, and to provide the correct linking between the elements of the list, we do it this way. It should be probably improved later. I can just return a new list of instructions, and the function above has a bit more freedom to generate a list of instructions and to replace one instruction with multiple instructions, but it is not important for now. So I actually need to set the operand on the old instruction and not on the new one, I think. And then we can create a starboard instruction. I suppose that we can copy this thing and we just say that it is not load word, but it is a starboard instruction, and the first argument of this starboard instruction would be T0, because it is the register that we use here, and the second argument is some offset from the stack allocated by this elnoalloc variable procedure, and that's it. Now we only need to concatenate to insert this additional instruction into the instruction list, and we append the alt instruction to the copied instruction, and I suppose that's it. So instruction malloc. This one probably taps. So here we had before an OR instruction, which is say then in x5, and then we moved this value into x10. Now we have multiple instructions here, and the stop word is before the OR instruction, which is currently run, if it is that instruction at all. It doesn't look so. And this is a similar case. X0 here is very wrong. X0 is a zero list. It should be never used this way, so it's basically a no op. And I see one error. And now it compiles. So splitting the screen, then go to the line. So we not only replaced the OR instruction, but also this AND instruction. And for the AND instruction, it seems that that this instruction is not used, therefore we haven't got any error, but we still need to replace it. The code will be basically the same, so we just copy paste it for now, and this is the wrong place. So this was this block. Exactly, and we say AND. AND is not a keyword, and we actually do not have to do anything. Because we do not use the instruction name explicitly, we just let it be as it is. So let us try to compile it, and after that we will think how we can pack this functionality into a procedure so we do not have to copy it each time. This is actually pretty the same as here. Here is T2 used instead of T0 as a temporary register, and here we use this slot word instruction. Yeah, I don't know. Let us just create a function that we call procedure in alloc binary. Let us say binary instruction, binary expression. Yeah, and we have the same arguments as this procedure, so it's basically the instruction list. We will see if we need something else, and we can copy this code there. And we need to define some some variables. I don't know if I need the instruction kind here. Probably not. So I only need these 5 variables, I think. So that does it. I don't like the name binary expression. I mean, this is a binary instruction, so an instruction with 2 operands and 1 target. But there are also other binary operands, and I cannot think of a better name for now. Alloc variable, binary expression. Let us call it at least binary operation. because expression is something from the abstract syntax tree, so an expression is something a language has, and these are really kind of probable operations. Operation is a name that I do like a bit more currently, so we say it is an operation, and to test it we can call this procedure here. So this is alloc binary operation, and we pass the original instruction to this operation, and after that I can remove this stuff here. The thing with the goto won't work, of course. It doesn't even make sense there. So this label isn't defined here. We have to remove it. Actually, we don't need this goto here because it will go straight away to the end of the procedure. I use it here in some cases. I think that I should just, yeah, it is used here. This can be replaced with an else block. Yeah, don't know. So let us first try to fix this thing here. And it compiles now, so we can remove this stuff now. And we can also replace the second block with the same thing. And now we can go and replace the further binary expressions, the result register with this pseudo register. And we just, so we had this order, then and we will continue with the multiplication. It's basically the same. So we just replace this temporary register with a pseudo variable multiplication. The operation remains as is, and we have to say that the result is in this binary variable, and then we someday we will support strings, and the strings in ELNA are records with two fields with the length of the string and a pointer, but currently our strings are just pointers that aren't null terminated because, as said, it is planned that the string contains the length of the string, so the null termination isn't needed, but currently we do not have that yet, and we need to write to pass the length of the string as argument for now, and don't forget to do it. So it looks already better. We have the variable name now here, and I just messed it up. So I left the place where we were, that were something like a tail operator, or for example, this we add a multiplication instruction once again, and look whether this works now. It is still broken. Let us look at the assembly once again. So we compare the two passes. I think that the instruction order, I've seen this last time, that the instruction order seems to be incorrect. What was binary operation? So once again, we have a pointer to an instruction, and I make the old instruction as the next instruction to the new instruction. Of course it is wrong. The order should be reversed. What does it mean? So we allocate storage for the new instruction. We copy an instruction, so the two instructions are the same. And the multiplication instruction should come after the store word instruction should come after the multiplication, or after this binary instruction. And we cannot override the instruction here. So the store instruction should be instruction that follows. Basically, this is the alt instruction. We say it is this this is this alt instruction. We allocate it and then we set the arguments to it. So this is the store instruction, and then we replace the operand or the multiplication instruction with the register, and the multiplication instruction is then just instruction, and this one is actually fine. Okay, that is fixed now. Alt instruction is not very useful name here. We can just call it store instruction. So we rename this variable into the store instruction. And to be honest, we actually I think that we need to copy the instruction, so we need the next element of this instruction to the store instruction, so that we don't break the list. I'm thinking, how can I do it without this malloc function? I can actually just create a store instruction, so I can say elna rtl instruction create, and we pass the instruction kind to it. And then we have to take the next element of the current instruction and to set it, so this instruction next, can I just say that the follower of the store instruction is the next element of the multiplication instruction. And when we can probably just remove this stuff here. And we also do not need to set the kind, because we set it in the create instruction. Then we can rearrange the statements a bit, so that we set the store instruction in one code block. Then we create this temporary variable, and we set the store instruction as the following instruction to the past instruction, and then we replace the argument. So that looks fine to me. Oh, of course I have to allocate the stack first. Yep. So let us replace a few more operators and hope that that works better. So we was by this multiplication operation, and we continue with the minus. That should fail because it will write binary into the assembly. Yes. And then we go back here and just add a subtraction instruction to the list and try to compile it now. And then we go to the plus. Pseudo binary the variables start with a dollar sign, since these are temporary variables, so pseudo registers, and this is done this way so that they don't conflict with the regular variables which are saved in the same symbol table, because the regular variables of the language cannot start with a dollar sign. So we now have XOR. I actually think that XOR isn't used anywhere. I cannot remember to use it. It is used for generating some operations, but I mean that I do not use in the compiler code itself, but it is used for code generation in a few places. So that's yeah, exactly. It didn't fail because it isn't used anywhere, but we still need to add a handler for it. So if we use it someday, that it probably works. So what we have else? Now we have the comparison things, and this is pseudo as well, with binary and 7, binary, pseudo and 7. Equality. And here it is used in two instructions, set equals 0 and branch equals 0. And it isn't really a binary instruction, so it has only two arguments. Branch equals 0 has label as an operand, and yeah, these instructions are a bit different. Let us do it later, probably even not today. Now I do not know what it was, so we replace it with 6 and 0, and here is the same, temporary, and 6 0. We just do a few more arithmetic operators, and I would take care of equality a bit later, because they work differently in RISC-V. So we have the reminder here. The reminder should actually, reminder is probably, I think RISC-V has an reminder instruction, because I think that x86 has pretty weird division reminder handling. So we just try to replace it as well with binary pseudo register, and here we put 7, and here as well. Yeah, I do not use the reminder as well, but I think that there is an instruction RAM, yeah. So here was it. So now we have the division. It is basically the same story, so it is a pseudo register. Yeah, I could make it so that I reduce some branches, but well, we have the same code everywhere, and after we finish porting the quality operations to these pseudo registers, we can get rid of this code and handle it at one place and not copy it into each branch. But we are going to do it next time, and I'm finishing here for today.